Today's video, I would like to introduce you a very nice problem. It's set as I, the bound from 0 to pi. We have this function 2 times is multiplied by x is multiplied by sine x divided by 3 plus cosine 2 times x dx. Okay, in fact this is very nice integral, but it's a little challenged. Okay, so the problem of this integral, when we have x is multiplied by sine x, we have two different functions in this product. So as long as x is in numerator is a problem itself, so we should think how to get rid of x from this expression to make the integral more reduced and simply to solve. Okay, before I move on to proceed with the solution, just I would like to remind you about, don't forget to support us with your like and subscribe. So if you would like to give the hands to this problem before we get to the solution, just go ahead, pause this video. When you ready, come back to see the full solution. Okay, let's get into the solution now. Before I start solving this integral, I'm going to work on denominator. So I'm going to transfer this expression into sine x. So we have this expression 3 plus cosine 2x. So I'm going to apply the trigonometry formula here. As you know, cosine 2x is the same as cosine square x minus sine square x. So we'll have cosine square x minus sine square x. So now I'm going to transfer cosine into sine x. So this one, cosine square x, is the same as 1 minus sine square x, which is 1 minus 2 times sine square x. Okay, so this one is given as 3 plus 1 minus 2 times sine 2x. By applying cosine square plus sine square equal to 1. Okay, so it's very simple. Now by adding 3 plus 1, by adding 3 on number 1 is given as 4 minus 2 times sine square x. So by taking number 2 as a common factor, I will have 2 is multiplied by 2 minus sine square x. Okay, I'm going to take this expression and insert it in denominator of this integral. So my integral becomes I from 0 to pi 2 times is multiplied by x is multiplied by sine x, or is divided by 2 is multiplied by 2 minus sine square x dx. So we'll have number 2 will be cancelled out from numerator and denominator. Now I have the same function in numerator and denominator, which is sine x. So in order to get rid of x from denominator, I'm going to make the substitution. So we need to find out the appropriate substitution which can cancel out x from numerator. So the convenient substitution here, by setting x equals to pi minus t. Okay, I'm going to differentiate this one is giving me dx equals minus dt. So now I'm going to change the bound as well. The bound, if you plug x with 0, is giving us pi as a lower bound. So the upper bound is giving us 0. As you plug in pi into x becomes pi minus t, and sine of x becomes pi minus t, all over this one. This one is 2 minus sine square. X become also pi minus t. Here it will become minus dt. The first thing we should do, we are going to cancel this minus sign and flip the bounds, become from 0 to pi. The second thing, we know sine of pi minus t becomes sine t, and also this one will be transferred to sine t. Now I will have a new integral of I equals from 0 to pi minus t, factor sine of t is all over minus sine square t dt. Now the integral becomes in terms of t as a variable. Okay, so I'm going to split this integral into 2 parts. So we'll have first integral from 0 to pi. By taking this pi outside of this integral, it's considered as a constant. is multiplied by sine t is divided by 2 minus sine square t dt minus another integral which is from 0 to pi t is multiplied by sine t all over 2 minus sine square t dt. Okay, now if you take a look carefully, this integral is similar to the previous integral. Okay, because we have x sine x, we have t sine t here, so the only difference is the denominator. So the denominator we get here when we divide the numerator and denominator by 2, because we already simplified by number 2 if you take a look carefully, because it was super easy to get here because we just simplified number 2 from numerator and denominator. We transferred this expression into this expression is giving us this one. So in order to go back to the original denominator, I'm going to simply multiply numerator and denominator by 2. Okay, if I'm applying the numerator and denominator by 2, is taking us to the same denominator. Okay, by transferring this one also to this one is giving us this one as you see it. And also this integral become from 0 to pi 2, it will have 2 x sine x is divided by this one 3 plus cosine 2x dx. Okay, why I'm changing this one into x? Because the value of the whole integral, it will be the same. Never ever change the value of this integral if you change the variable from t to x. Okay, so this one is a I integral. Okay, as we have here. Now I have this integral I, which equal to this one pi from 0 to pi. I'm transferring t to x, I'm transferring t into x, it will be the same. Sine of x is divided by 2 minus sine square x dx minus I integral. Okay, so now it's very easier. Now the integral become more simple to solve, but just we need to bring the minus I to the left hand side of this equation, become 2i by taking off this I from the right side of this equation. So now I have a new expression. Now again, so I have sine x and sine square x. In order to solve this one, the best way to solve this one, we are going to put a new substitution. Okay, I'm going to transfer this sine square x into cosine x. So it's very simple. We have 2 minus sine square x. By transferring this sine square x into cosine, I will have 1 minus cosine square x. 2 minus 1, it's 2 minus 1 is giving us 1. Minus 1 minus cosine square x, which is plus cosine square x. Okay, I'm going to take this value and insert it into denominator. Okay, I integral equals pi from 0 to pi sine x. I will have sine x is divided by 1 plus cosine square x dx. Okay, by putting z equals to cosine x as a new substitution, by differentiating this one, I will have dz equals minus sine x dx. So dx equals minus dz is divided by sine x. Okay, now we have 2i equals pi is multiplied. I'm going to change the bound. The bound, if you insert 0 into cosine, is giving us 1. Cosine pi is giving us 0. The integral from 1 to 0. I'm going to leave sine x as is it. I will have sine x over cosine x will be replaced with z. I will have z square, 1 plus z square. Dx will be replaced with minus dz is divided by sine x. We will have a nice cancellation here. Sine x will be cancelled out. So we'll have this minus sine will be cancelled out by flipping these bounds from 0 to 1. So we'll have the new integral. We'll have pi from 0 to 1 dz is divided by 1 plus z square. Okay. Now we have a standard formula for the arctangent, which is giving us pi of arctangent z is evaluated from z equal to 0 to 1. Plug in number 1 into arctangent is giving us pi over 4. Plug in 0 into arctangent is giving us 0. Our integral become pi over 4 is multiplied by pi, which is pi square over 4. Okay. Now we have 2i equals pi over 4. That's mean I equals pi square over 8. Okay. Here is the value of I integral equals pi square over 8. I have done with this integral. If you are interested in watching this one, don't forget to support us with your like and subscribe. Thank you for watching. I will see you in the next video. Bye.